Today we're going to begin Chapter 5, which deals with the chemistry of acids and bases. Before we get into the details, chemical reactions and such, let's take a look at some of the everyday properties of these materials. Acids are normally sour. If you taste lemon juice, it has a very sour taste because it contains citric acid. Same thing is true of vinegar. Vinegar contains acetic acid, which makes it very sour. Now, most food products contain acids. That sour taste is actually pleasing if you cut it with other things. For example, oil and vinegar salad dressing. The vinegar gives it that sort of zing with the acetic acid, and then all of the different herbs that you put in there moderates that. It makes it a very pleasant taste. If you've ever watched the show Chopped, they'll often tell the contestants, you need more acid in that food. And so they might use lemon juice or vinegar to do that. Now, bases, on the other hand, taste bitter, which is really bad. I'm not going to actually taste a base, and I don't necessarily recommend you do it either. But if you've ever had your mouth washed out with soap, it tastes really bad. Liquid plumber or Drano, the drain cleaners, are very powerful bases. You have to be real careful with those things. Bases have the ability to dissolve organic material, things like grease and fat and hair. And that's why we use drain cleaners, which are very basic, to clear out those organic types of materials you might get a drain clog with. On the other hand, acids tend to attack metals. Whereas acids don't do a very good job of destroying organic material, they are really good at dissolving metals. So we're going to do another demonstration here in just a moment, where we're going to add some very strong base and some very strong acid to a couple of pieces of iron and see how each of those reacts. I mentioned a moment ago that bases tend to attack organic materials and acids attack metals. So we're going to test that by adding some sodium hydroxide, which is similar to the compound they have in drain cleaners, a very powerful base, and we'll add some concentrated hydrochloric acid to the other test tube. So let's go ahead and put on some safety glasses here. We'll add some sodium hydroxide to our first piece of iron, and let's see if it actually does anything to it. All right, keep an eye on that. In a moment we'll get a closer view, but right now it doesn't look like anything is happening. So let's go ahead and add some concentrated hydrochloric acid to the other test tube. Now, let's keep an eye on those two things. I'm already starting to see bubbles coming off from the hydrochloric acid, so why don't we move in for a closer look. Now, if you look more closely, you can see that the test tube with the hydrochloric acid is turning yellow. That's because the piece of iron is actually dissolving, and there's lots of bubbles of hydrogen gas coming off of that piece of metal. When we get to the next chapter, in Chapter 6, we're going to learn all about chemical reactions between acids and metals, amongst other things. Now, if you take a look at the other test tube with the sodium hydroxide, clearly nothing is happening. It's interesting. I used to work at Burger King many years ago, decades ago, and every night we had to clean all of the grease off of the stainless steel broilers, and we would basically dunk them into a vat of sodium hydroxide. It would dissolve all of the grease and fat that had collected during the day, and it left the metal perfectly shiny and clean. Another property that acids and bases have is their ability to change chemicals called indicators to different colors. Some of you may have heard of phenolphthalein before. This flask over here, which is for a demonstration we'll be doing in a couple of minutes, has phenolphthalein in it. Phenolphthalein is pink in the presence of bases, and it's colorless in the presence of acids. In the experiment that we'll be doing this week, we're going to be using a homemade indicator, which is cabbage juice. I basically ground up some cabbage, and when you watch the video for the pre-lab, you will see how all of that has taken place. Cabbage juice, unlike phenolphthalein, can change a number of different colors. We have these little color strips here, and you can see it goes from red to purple to blue to green to yellow. So lots of different colors. And in the video for the lab, if you want to do this at home, it shows exactly how you can prepare your own cabbage juice. So acids are on the red end of this little chart. So let's put some vinegar in one of our cups. And vinegar, of course, as we mentioned a little while ago, is acidic. It contains acetic acid. Let's add some cabbage juice to it, and it turns a lovely red color, which we would expect because the pH down here of, say, 2 to 4 is in the red color range, and vinegar usually has a pH of about 2 to 3. Ammonia, on the other hand, is a cleaning product. And cleaning products are normally basic, so we would expect the cabbage juice and ammonia to change to one of the basic colors, say the blue, green, or yellow. So let's take a look. We'll add some cabbage juice to our ammonia. Ooh, and we get a lovely green color. So cabbage juice is a very handy indicator. You can use that to determine whether something is acidic or basic, and even get an approximate idea of how acidic or basic it is. Now, in the laboratory, instead of using cabbage juice, chemists use something called universal indicator. So universal indicator is sort of a blend of a number of different individual indicators, each of which changes different colors at different pH values. So you can use universal indicator like you do the cabbage juice to show a variety of different colors at different pHs. So we're going to do our next demonstration in which we're going to be using some universal indicator.